key. All right. So today's lesson, tomorrow's lesson, really focus in and see if we can be where we need to be. Okay, everything starts off with slope. We've already been introduced to slope. There's a couple different ways you can look at slope. One way is to look at it as the ratio, right? When you see the word ratio, you should be thinking fraction. It's the ratio of the rise over so the rise is the vertical over the run, which is the horizontal. All right, don't want to gross anybody out, but you guys are kids and you don't mind being grossed out. Plumbers know rise over run very well. They know slope very, very well, because when they come to your house, and let's say they're going to put a drain in, and maybe you want a new toilet down in the basement. So they're going to jackhammer your floor, and then they're going to have to put that drain in, the drain, and it's going to have to hook up to the waste in your house. And somewhere in your basement there is your waste line. And so they have to hook up from that toilet to that waste line. And you know what? They want to make sure they have the right amount of rise over run. So you don't need to draw this, but if your commode is there, my great drawing ability, and the drain would be right there, you're going to have to connect that. And I don't know, maybe the house drain is right here, heading down. And if the plumber does one of these jobs and he has the wrong rise over run, it's not going to be pretty. It's not going to smell good either, because he's got the wrong slope. He's got a positive rise over a positive run. It's going up, and water doesn't flow up. So that would be bad. That would be really, 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 really bad. But if he's wise and he's got the right rise over run, it wouldn't be that drastic. They have their amounts that they have to do. He's going to have an actual negative rise over a positive run that will allow him to have a downhill slope that will allow him to have everything to flow properly, and he'll be very, very happy. So one way of thinking of slope is rise over run, and that's in thinking about plumbing. Steps have a certain slope. Matter of fact, the vertical part of a step is called a riser. And then you have a tread, which would be the run. So you got riser is the rise and the tread is the run. And there's a certain amount of slope to steps. A roof is commonly called pitch, but a roof has a slope, a certain rise over run. And the further north you go, the greater the slope of a roof. Anybody know why the roofs are sloped more as you go north, Quinn? Not the rain, but the snow. They have more snow. The steeper your slope, the less snow piles up on top of it. If you've got a flattened roof like we have around here and you get a heavy snow load, your roof might be collapsing. And so the farther north you go, the greater the rise over the run for the roofs. But slope, it's very, very important. It's vertical change over the horizontal change, right? What is slope? Vertical change over the horizontal change. Sometimes we simply say this: slope is change from the horizontal. If you had a horizontal line, is there any change in that slope? Does it have a slope? No. It's no fun to go skiing on a horizontal surface. There's no slope. But as you change from the horizontal, now you have a slope, and that's a little bit more fun to ski on. All right, so the slope is the rise, and this is our change in y. Triangle means delta, or is you say it delta, but it means change in. So delta y means the change in y, and the run is delta x, the change in x. So that should make sense, right? Because y is the vertical coordinate, right? The up and down coordinate, and x is the horizontal coordinate. So rise, change in y over x, change in run. And when you look at the slope, you're looking at positive. Um, top part would be up. A negative top part would be down. All right, we'll look at that in a minute. Because remember, the top number is the vertical change. So if you got a positive top number, it's up, positive. If you got a negative top number, it's down because the top is up or down. What's the bottom? Left or right. So positive is right, negative is left on the bottom, just like you would think, at least hopefully you would think that way. All right, so let's take a look at some aspects here. First off, the first one is positive slopes. No matter what 2 points you look at, they'd be in the same ratio. So I just picked 2 points here. I picked the point right here and the point right here. And to get to the 2 points, you would go up 4. That would be a positive 4, right? And you would go left, right. You would go right 3. And we have a 4/3 slope. Our vertical change was 4. And our horizontal change was 3. Right? We went up 4. And we went to the right 3. Up is positive, right is positive. Therefore, we have a positive 4 over a positive 3. And every positive slope goes up to the right, right? As you move left to right, what's happening? Slope is going up. Remember domain and range? As you start to the left with your domain, your range is way down here, some negative value. As you keep moving right, what's happening to your domain? It's getting bigger. Now when you get to 0, your domain is about -3. When you get to 2, your domain is 0. When you get to 3, your domain is about 1.5. When you get to 5, your domain is 5. As you move left to right, what's happening to your domain? I'm sorry, to your to the output. As you look at the domain, it's the output is getting larger. So as you go left to right, your output is increasing. That's a positive slope. So the next one is a negative slope. And that's this line here to the right. You know, and you look at it, you've got a negative slope. What's happening as you move left to right? The line is going down as you move left to right. The line is heading down. It's got a negative slope. So what's the vertical change? Down 3, that's a -3, right? Remember, the top number is always vertical, up or down. And what do you have to do to get back to the line? You go to the right 2. That's a positive 2. We get a -3/2. Hey, that's a negative slope. That's a negative slope. So negative slopes always go down to the right. As you go left to right, they're heading down. Positive slopes, as you go left to right, they're heading up. Okay, you need to keep that straight. That's just something that every student should know, positive and negative slopes. Okay, next thought here. So number 1, the formula to find the slope of a line through, and this is, I'm going to do it in blue, you can do it in black, 2 points. This is a formula you need to memorize. How do you find the slope between 2 points? Well, here's the formula. Because the top of the slope is the vertical change, it's going to be y sub 2, that's a subscript of 2, minus y sub 1, that's a subscript of 1. What is that? That's the y coordinate of 0.2, that's, for our example, that number right there, right? Minus the y coordinate of 0.1. What does that give you? The vertical change. How much is this thing changing vertically from one point to the next? So the bottom is the horizontal change. So what do you think the bottom would be? Say it if you know it. X sub 2 minus x sub 1. Exactly right. All right? So it's the vertical change over the horizontal change. I always encourage my students to label their points. You know what students want to do? here's what I see students. They want to, when they're just looking, they think this is x1 and this is x2. Well, no, that's not right. Every point has an x and a y coordinate, right? So this is the x coordinate of point 1. This is the y coordinate of point 1. That's what x sub 1 means and y sub 1. X sub 1 means the x coordinate of point 1 and y sub 1 means the y coordinate of point 1. So over here we have the x coordinate of point 2 and the y coordinate of point 2. Now you might say, how do I know which one to call point 1 and point 2? How would you know? What would the answer be? Anybody know? How are you going to know which one to call point 1 and point 2? Graph them? Nope, it's easier. Wesley? Okay, you can always call the first one point 1 and the second one point 2. But in reality, what? It doesn't matter. It'll work either way. It doesn't matter which one you call point 1, which one you call point 2. Most students call the first one point 1 and the second one point 2. All right, let's solve then A and B. So again, my advice, label x sub 1, y sub 1. Label x sub 2, y sub 2. I've seen many a student get them mixed up. All right, so the formula's right up above. If you're doing homework, you're going to write the formula for every problem, right? Because that's going to help you to remember the formula. So when you do homework, make sure every time you write the formula for every single problem where you find the slope between 2 points. So now we're ready for M equals, what's y sub 2? It says 12. That's a minus sign from the formula between them, correct? What's y sub 1? That's a 9. It's clear for me to see because I label my points. What's x sub 2? It's a 6. Oh, there goes the yellow again. It's a 6. Got the minus sign from the formula. What's x sub 1? It's a 1. And now I'm ready to finish it off, right? Again, though, in your homework, make sure you write the slope formula first. I need you to memorize it. You need to memorize it. All right, so what do we end up with? A 3/5. The vertical change is 3, and the horizontal change is 5. Up 3 to the right 5. Positive 3/5 slope. Okay, I want you guys to see if you can do B. Go ahead and find the slope of B. Again, if we were doing this in homework, first thing we do is write the formula. Go ahead and solve. Find the slope of the 2 points in B. Go back. All right, so let me unfreeze this. All right, so hopefully if you did everything correctly, you would have a 1 minus 4 in the top. And that would yield you a negative 3. But on the bottom, I hope you dealt with that. The negative from the formula and the negative from the coordinate. So what do you have? A negative 3/8. How many got negative 3/8? Okay, good. So a lot of you avoided the pitfall on that. A lot of people will mess up with the minus. Just be careful there, right? Be careful there. So how many of you got that right again? That was a bunch of you. All right, awesome. You guys are amazing. Okay, number 2. 2 special slopes. All right, the first one is a horizontal line. This should be red. A horizontal line. Horizontal slopes are really boring. You don't want to ski a hill with the horizontal slope. Give me that. Yeah, horizontal slopes. So what's the value of this slope? What's the vertical change over the horizontal change? Well, let's run the formula. and then we'll fill in that last blank. Okay, so I gave you, if you look here on your sheet, I gave you 2 points along this horizontal line, correct? Okay, so we got these 2 lines along this horizontal line. And let's take a look at the value of the slope. Let's run the slope formula. Okay, so let me get rid of those circles for you. Let's do y sub 2. That's a 2. Oh, I'm over here. Let's go on the right. Y sub 2 is a 2. Minus y sub 1 is a 2. X sub 2 is a 3. And x sub 1 is a minus 4. Got my parentheses in the wrong place, but who cares? Okay. So when you go to simplify that, if we look at the top, 2 minus 2, we all know is 0. And on the bottom, you get 3 plus 4, and that's going to be a 7, right? And everybody knows that 0 divided by anything is 0. So what kind of slope do horizontal lines have? A 0 slope. Every horizontal line has 0 slope. And that makes sense because look, how much has this changed from the horizontal? None. It's horizontal. There's no change. No change is 0. Okay. And no matter what 2 points you pick along now, any horizontal line, you always get a 0 slope. Always, 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 always. Did I say always? Always. Second one. Let's deal with a vertical line. A vertical line. So before we fill in the blanks, let's go ahead and run the math again. So I chose 2 points, right? You see your 2 points there? Okay, so there's the slope formula. So y sub 2 is a 4, and y sub 1 is a 1. On the bottom, the horizontal change, x sub 2 is a negative 3, and x sub 1 is a negative 3. Again, we got the negative and negative going on. So now when we simplify, the top is a 3, and the bottom is a what? 0. And we all know that anything divided by 0 is infinity. Or some like to say undefined because you can't reverse it, but it's infinity. Look at this slope that I'm holding right now, right? It's horizontal, correct? All right, this slope's getting bigger now, right? Because it's no longer horizontal. Do you agree? It's getting bigger. Do you agree? You'd like to ski that more than the first one. It's getting bigger. Do you agree? Rather ski that one, right? It's getting bigger. Do you agree? It's getting bigger. Do you agree? That'd be a tough one to ski. You better be an extreme skier for that one, right? Jackson Hole, Wyoming, the slope looks about like that. But it's nothing today to the skiers, right? It's getting bigger, right? So when I go vertical, what word would you say? No, watch. Bigger, 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 bigger. What word would you say? Biggest, biggest, right? Bigger, 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 bigger till it's vertical is biggest. What is the biggest number? Infinity. It's infinity, right? And it is infinity. When you go vertical, you get division by 0. So a vertical line has, and I'm going to go in green here, infinite slope. Infinite slope. Or is, again, some people don't like to say infinity, but when you get to calculus, they're going to tell you infinity, undefined. So we might as well learn it now. It's really infinity. Because it doesn't go backwards, they want to say it's undefined. All right, so know those 2 things. Horizontal line, 0 slope. Vertical line, infinite slope. Let's go to the next thing. To find the slope of a graphed line, look for 2 clear points. Look for 2 clear points. All right, so if you look on the graph, hey, right here is a very clear point. Definitely at the point 1, 5, right? Do you agree? Now, again, you're trying to look for a perfect intersection. I don't see another one along the line until way down here. Do you agree? Those are two clear points that we can see. Okay, we can use these points to find the slope. What do I have to do vertically to get from this point to this point? What do I have to do? I've got to go down, right? Is down positive or negative? Negative. Okay, so what's my vertical change going to be? Negative. And how much do I go down? How much are you going to go down? Well, just start there. That's 1, 2, 3, 4, 5, 6, 7. I went down 7. It's a negative 7. The vertical change is negative 7. The bottom is the horizontal change. All right, from now I'm over here. What do I have to do to hit the line? 1, to hit the point. 2, 3. I go to the right 3. That's a positive 3. I just found the slope of that line. It's a 7/3. Right? Slope is negative 7/3. Thank you. Right? Do you agree? Negative 7/3. So what do you got to do to find the slope of a line already graphed? You got to find two clear points and do the vertical change over the horizontal change. By the way, we should have already known this was a negative slope, right? Because what's happening as you go left to right? It's going down. Positive slopes always go up, left to right. All right, on the back. Graphing a line using a known point, and the slope. Graphing a line using a known point and the slope. All right, so look at A here on the left. Here's the known point, right? 2, 1. We all know how to graph that, don't we? Go ahead and put the point 2, 1 on your graph. Go ahead and plot 2, 1 on your graph. I hope you went right there. Is that where you went? 2 to the right and 1 up, 2, 1. Okay, class, say it. What's the top number of the slope to 2 mean? What change? Vertical or horizontal? Vertical. And a positive 2 is up or down? Up. So we have to go up 2. From that point, go up 2. The bottom is the horizontal change. Left or right? Do we go left or right for the 3? You go right. Positive is right. Go right 3. 1, 2, 3. And I'm right there. Everybody follow that? We went up 2. We went to the right 3. Okay? That's where the line is. Go ahead and draw the line through those 2 points. We just graphed that line using a point and the slope. Follow? Let's do the next one. Go ahead and graph the point -1, -2. -1, -2. Hopefully you put it right there in quadrant what? What quad is that? 3, right? Quad 3? All right, so we're in quad 3, left 1 and down 2. All right, this slope's a little bit more interesting. What do you do with the 4? What does that tell you to do? Josh? Go up 4. Awesome. So from this point, go up 4. 1, 2, 3, 4. You go up 4 spaces, not to the number 4. I'm here. 1, 2, 3, 4. Go up 4 spaces, right? From where you're starting. Well, wait a minute. There's no bottom number. Do I not do anything? John? Right 4. How many agree I go to the right 4? How many disagree? What do you want instead? Kyle? Go to the right 1. Why should I go to the right 1? I don't see any 1. Oh, why are you so quick to give up? Of course it's 4 over 1, right? Right? We're going to the right 1. And that's our second point. Yeah, don't give up so quickly. You were right, and that's where our line is. All right there. All right, so remember that I chose that on purpose to show it to you so you'll think about it too. If they say the slope is 4, it's really 4 over 1. If they say it's 7, it's really 7 over 1. They say it's 0.2, it's really 0.2 over 1. All right, last thing, reading a graph. What is the value of the slope of the graph to the right? Gabby, question? Did we not fill in the blanks where? Oh, up there? Okay. So graphing a line using a known point in the slope. Plot the point first. Yeah, that's really important. Then use the slope to plot the second point, just like we did. Plot the point first, then use the slope to plot the second point. Draw the line between them. Voila, you are there. Okay, right here at the bottom. What's the value of the slope? Anybody read it off the graph? Can you read it? What's the vertical change? Say it if you know it. What's the vertical change? Say it if you know it. 25. What's the horizontal change? What's the horizontal change? 20. So 25 20ths, if you were to reduce that, and we do reduce our slopes, don't we? So what do you end up with? 5/4. For every 5 watts, for every 5, look at the graph, for every 5 watts, dollars, you get 4 what? Pages. Exactly right. For every $5, you get 4 pages. That's real life, and that's the real life use of slopes and y-intercepts. All right, homework tonight. Pay attention. This homework is really, really key section. Page 242. Some of these are quick, so don't spaz out. 1 through 12. Some of these are one-word answers. 17 through 21. 25, 26. 29, 30, and 40. 1 through 12, 17 through 21, 25, 26, 29, 30, and 40. I am going to be here after school.